Okay, so welcome to this Google Hangout training session. Um, this time we're talking about introduction to the Cisco ASA, and it's by Untitled Technologies. My name is Adiola Wakadi. In CCIA Security. Took my CCIE lab in 2010. Since then, I've been involved in several projects. Recently, I've been involved a lot in writing articles, and that's where this is born out of, basically. So we're just going to go right into it. The first thing that we're going to talk about, I need to constantly check that everybody is still following me because right now I'm not using two screens, so I can't really see my Google Hangout. So sometimes I'll have to stop and then flip back to the Hangout and see if everybody's still there. Okay, we also have somebody, Shay Shay just joined us. Thank you for joining us. So I'm going to continue now. So first of all, we'll take a recap of firewall technologies in general. Now, the first type of firewall technology, which we call first generation firewall, is the stateless packet filtering. I need to change this to my pen. All right. Okay. So we have the stateless packet filtering, also called static packet filtering. So basically, if you have a firewall, yeah, this is supposed to be a firewall. Anyways, you get the point. Let's assume this is the internet and this is your internal network, so your LAN. Now, when you talk about static packet filtering, you basically have a firewall or something that is sitting at the edge of your network, and it's basically just one way. It sees everything in one way. It does its filtering in one way. So if for instance, there's a host on this LAN and there's a server here. Now, once this host tries to connect to this server, this connection may be permitted based on whatever rules that you have. But then when this server tries to reply to the host that initiated that packet, this firewall cannot determine that it's part of the same connection. So it doesn't know that this is actually a reply. And that is the problem that we have with static packet filtering. It's just one way. And the one thing you should remember is that static packet filtering happens between layer 3, or it works on layer 3 and layer 4. So basically you have your TCP, for example, port numbers, IP addresses, and things like that. So now that's the first firewall technology that we have. The second one that we have is stateful packet filtering. Now, stateful just adds state to it. So it knows that connections are part of the same thing. So for example, let's take the TCP three-way handshake. We have SYN, SYNAC, and ARC. Now, the problem with stateless is that SYN, ARC, they'll just all be individual packets. But with stateful, it knows that all these are part of one connection. So that's the advantage of stateful over stateless. And stateful also occurs at layer 3 and layer 4. Now, the next one that we have is proxy firewalls. A proxy firewall, basically, proxy is something that acts on behalf of somebody. So taking this our example again, you have your host, you have your firewall, and let's say this is a server here. In the other instances, the server would see the connection coming from the client. But when you're talking about a proxy, it's actually the user. The user makes a connection to the proxy firewall, and then the proxy firewall makes a connection to the server. So that's just what proxy is on behalf of something else. And then the last one that we have is deep packet inspection. Now, one thing I should have mentioned is that proxy firewalls, depending on which one you're using, it actually occurs either layer 5, between layer 5, I'm having a problem with my pen, layer 5 or layer 7, or from layer 5 to layer 7, basically. Now, deep packet inspection, when we get to the ASA, we'll find out that the ASA has static, stateful, and then deep packet inspection. Deep packet inspection also happens at layer 7 or it can also see into layer 7 packets, but it goes all the way from like layer 3 all the way to layer 7. Let me just make sure that everybody is still following me at this point. Okay, I can see 4 viewers. I don't see any questions. I don't see anybody complaining. So I'm going to assume that you are following me. Okay. So that's basically it on the firewall technologies that we have. Let's move on. Now, the Cisco firewall products that we have. Uh, I just got a message. Let me check that message. Okay, yes, I'm being followed. Thank you very much. Okay, so the firewall products that we have are the ASA 5500 series. Now, these are the ones that we were basically familiar with: 5510, 5520, 5540, 5550. Now, the sad thing, or at least to me, it was a bit sad, was the fact that I noticed that these are now end of life. So many of them became end of life. Some of them from March 2013, some September. They just released some of them. Basically, the 5500 series is now end of life. And then Cisco has moved on to the 5500X series next generation firewall. Now, I'm just going to tell you, this next generation firewalls are the same thing as the 5500 series, but then they have this next generation firewall services, as we're going to see. Now, the names 5512X, 5515X, 5525X, and things like that. I also just noticed that Cisco has this cloud firewall. I noticed recently that Cisco is moving to, or they're pushing some cloud technologies, and basically they have a firewall product for their cloud technology, which is the ASA 1000V cloud firewall. And I thought to mention this, that you also have the Cisco iOS firewall. It's not a standalone application in itself, but the fact that you can turn on some features in the firewall, for example, you can have like the iOS IPS. You also have the zone-based firewall and things like that. And these features are also pretty cool, but they happen on the iOS, so they are not like dedicated security appliances. Now, this next generation firewalls that we talked about, let's look at the services that we have under them. So Cisco, we have this application visibility and control. We have this web security essentials, intrusion prevention. We also had intrusion prevention in the 5500 series, but you needed like a model. Um, well, Cisco AnyConnect VPN, and then you have this cloud web security. Now, the cool thing for me was the web security essentials. I remember working on a project where we had to deal with, we had a firewall, and then we still had to use another web filtering solution. But with this web security essentials, I believe Cisco has incorporated some of this web filtering into it, apart from just their basic URL filtering. So moving away from the normal 5500 series, it's nice. Like I said, the 55 5 5, I think I need to start writing in this pen. Just okay, so the 5500X is just the 5500. I'm scared of writing the 5. Pen work. 5500 plus the next gen firewall services. Yeah, of course, there are going to be a couple of other things, but as an engineer, the thing that you need to know is that your basic configuration and everything still remains the same as you have from the 5500 series, but then you just added this next gen firewall services, which are all this that I've mentioned here. Cool, let's move on. Now we're going to get into the concept of the ASA, and all this is building us up to go to the config line or the config terminal. Now the first concept that we have to look at is the security levels. Let me pause and check the questions and answers and make sure that there are no questions. Remember that you can ask questions at any time. Just drop your questions and I see them. I'm going to answer them. Okay, right now I don't see any questions and I don't see any comments, so I'm just going to continue. Now you have security levels. So the analogy I always give is, think about it. If you are in working in a bank, for example, you probably have like a cafeteria and then you have the vault. Now, the security level in the cafeteria is much lower than the one in the vault, right? Now, this is what security levels basically talk about. The ASA is able to split different zones of maybe a network or something. It's able to split different zones into different security levels and assign them like different security levels. So, for example, on the ASA, you can assign security levels between 0 and 100. 0 is the lowest and 100 is the highest. Now we usually have, if you're dealing with a basic configuration, you usually have inside and outside. So inside is just your LAN and outside would probably be like your internet. And inside we assign inside to 100 and outside to 0. Now sometimes you have something in between like a DMZ and you can assign your DMZ to 50. Now you see how I just need to check. I just got a message, so let me just check that. Uh, okay. I need to add somebody else. I need to add Tolu to this. Okay, so sorry about that. I'm going to get back to the training now. So you're going to see how the security levels add up. Basically, so we've talked about inside, outside, DMZ, and things like that. But on the ASA, you can assign between security levels 0 and 100. Now, I'm going to talk about the default traffic flow. Now, when we talk about the whole point of using security levels is so that you can know, or so that the ASA can determine how traffic should flow. Now, one analogy I like using is a mountain that has like a stream. So this, pardon me, this is supposed to be water. Yeah. So water can flow from the top to the bottom, but except you're using like a pump, water can flow in this reverse direction, right? So that's the concept with the default traffic flow. From a higher security level to a lower security level, traffic can flow. But from a lower security level to a higher security level, traffic cannot flow. So just every time you want to think about it, just think of the whole mountain and water flow model. Can water flow down a mountain or can water flow up a mountain? Now I have a diagram here that is going to help us explain it further using a network diagram. So you have a host, you have the ASA. Now the host is on the inside, and then you have an external server which is on the outside. Notice that uh, notice that this is security level of 0 and this is security level of 100. Now by default, traffic will flow from the higher. So this is the higher one. Really sorry, we lost connection at some point. So this is supposed to be where we stopped. I'm just going to go back one more slide to see if everybody followed me up to a particular point, and then I'll continue from there. So the last thing I talked about before the error happened, or the last thing I think I talked about before the error happened, was I talked about the waterfall model and how water can flow from a higher level to a lower level, but not in the reverse direction by default. And then I talked about how the security level affects the default traffic flow. So here in this diagram, I explained that a host on a higher security level can connect to an external server on a lower security level, and the return traffic would be allowed back by default because the ASA is stateful. So it has a stateful, it can do stateful packet filtering. And I also mentioned the fact that if the external server tries to connect to the internal host, that will not be allowed by default. There are ways to edit this default flow. I hope we're still on. I'm just going to continue now. Okay, I need okay. Now, I'm going to continue with firewall modes. There are two firewall modes that we have. The first one is routed, and the second one is transparent. Now, the routed mode, the firewall is basically a hop, so it's another hop in the network. But when you're talking about transparent mode, it's just like a bump in the wire. So bump in the wire. Now the thing is, you use transparent mode when you have like a preset network and you can't really change the way things are, but you need a firewall to be placed in it. So for example, you have, let's say, something like this, a LAN or something, and you just want to place your firewall in between here. I need to learn how to draw the firewall. Okay, so that's it with firewall modes. And then the last thing that I want to talk about with concepts is security context. Now, with security context, you can split your firewall. What was I trying to draw here? Okay. You can split your firewall into multiple devices. So just think of this like virtualization. Now, with security context, one firewall can serve as 3 firewalls, as 4 firewalls, of course, depending on what license that you have. So under security context, we have either you're running single mode or you're running multiple context. Multiple context. Now, if you have any beef with any IT engineer who is working with you or something, tell the person to configure transparent mode, that's transparent firewall mode, and multiple context. That's a good punishment for anybody who errs. Okay, so let's move on. Now we're just going to get straight into, because I think we spent a lot of time. We're going to get into the configuration immediately. This is the basic config that we're going to use. I have a host on the 192.168.10.0 network. Inside, I'm going to assign 100 security level, and then outside, I'm going to use 0. And then I have a router here, right? So we're going to test. We're going to see everything that we said. Well, not everything, but at least some of them. Security levels. We'll see the traffic flow too. We'll see the default traffic flow, and we'll also see how to edit that default traffic flow. I'm going to stop sharing this right now and get into configuration. Skip. 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 Okay. Is everybody still here? Yes. Yes. We have one viewer on the web. Okay. Okay, so I'm going to share my whole screen right now. Yeah, so my head is showing right now. Is everybody fine with my head and it's not half head? Okay. So I have my setup in GNS3. My firewall, my router. The thing is, you can't connect a host directly to a firewall when you're using GNS3. So that's why that is that. It may take a while for this to start up, especially with the ASA. So in that time, I'm just going to show you what I configured on the router. And so let me just set up console settings. I'm just going to change some settings so that you guys can see. Okay, so the only thing I've done on my router, of course, is yeah, I have done my interface settings, and the router is 192.168.20.2. If I check my routing table, I have a static route to connect to 10.0, which is the network behind the ASA. That's basically all, except that I've also done some. I've set a password on the terminal lines. That's all I have done on the router, right? So I'm just going to go to the ASA. which is still loading. Okay, so now let's start. This is from basic Cisco days. You can't configure anything while you're in this user exec mode. You have to get into privilege exec mode and you use enable. Now the ASA is going to ask you for a password. If you don't know, you type Cisco, you type PIX, you type different things. But the thing is, you just need to press enter because there's no enable password for an ASA that you're just starting up. It's quite similar to the IO. So we've seen enable, we've seen config. These are things that we're familiar with from the router. Now this is just something about improving ASA platform. I don't really care about that. Okay, and right now you can see that we can do, like, we can view our running config, our startup config. Now one of the cool things about the ASA is you can do a show command from anywhere. So of course you can't really do it when you're in user privilege exec mode, but you can do it when you're in config and you don't need to put a do in front of it. In fact, if you put a do, the ASA is not going to recognize it. So I can show run and you can see everything that I have. Increase this. Okay, so the first thing that we want to configure is our interfaces. Now this is the one connecting to outside. It just makes sense for you to use 0 as outside and 1 as inside, and then you can use DMZ as 2, like that. So interface gigabit 0. Now there are 3 things that you have to configure to bring an interface up. The first is the name. So you actually have to assign it a name, and this name, this is 0. So this should be outside. Now by default, the ASA, when it sees outside, is going to set it to 0. Actually, when it sees anything apart from inside, it's going to set it to a default of 0. We're going to see what I mean by apart from inside. So the first thing that you need to do is to configure the name if. The second thing that you need to do is to configure the security level. Now this is the security level that we talked about. Now our security level is of the outside is 0, so we don't actually need to configure it here because the ASA has done it for us by default. But I'm just going to show you for completeness sake. 0, and then of course put an IP address. The IP address of our outside is 20. I'm going to use .1. This 255. So as you can see, it's pretty similar to the iOS config, and then of course I'm going to no shot it. That's the first one, and then I'm going to configure my inside interface. Name if inside. Now inside, outside are names that you can, it's discretionary. You don't have to use inside, outside. You can use anything that you want, but if you set an interface to be inside, it's going to, so let me just press enter. It's going to set the security level for that interface to 100. Now anything apart from inside would always be 0. IP address 192.168.10.1.255, and then no shot. Right, so let's just try to ping and see if we have connection. Ping the router. So I can ping the router, and my host, I need to turn off my Norton firewall. So ping 192.168.10. I think this should be 100. Okay, so I have connection. Basically my ASA has connection to both sides of the traffic, right? Now we're going to leave everything like this at the default, and then we'll try to see what the default traffic flow is. This, let me see if I can you guys see this? I don't think so. Let's see if I can increase the font or something. That looks weird. Does it look weird for you guys too? It's fine. I'm just going to go from this host. So I'm going to open a connection. This inside this host is actually my system, right? So anything I do on my system is actually represented by this host. and I'm going to try to connect to this router. I'm going to use telnet, and then we'll see if that goes through. That should go through, right? So I'm just going to use PuTTY. Okay, so that host is, or that router is 192.168.20.2, port 23, telnet open. You know, I have no clue why it's taking so long. Let me just open a command prompt and make sure that, oh, it still looks weird. Ping 192.168.10.1, which is the ASA. So I can ping the ASA. I don't like how this looks. Okay. And the routing table of this system to make sure that it can reach 192.168. Of course, I'm sure you understand that I've had to tweak some things and add the routes to my Windows system. So 192.168.20.2, it should go through 10.1. But then I can see that it's going through a funny interface, which is my Wi-Fi. That's why it's not working. Oh, okay. So route delete 192.168.20.2. Do you know what? I'm just going to write our configuration. So you can copy run start, or you can write, or anything. And I'm going to take out this. I'm just going to use a router. So let me quickly configure this. The interface, call it 10 dot whatever. Okay, let's use 101. And I'm just going to route everything. Default gateway to be 10.1, which is the ASA. That's all I need to do. So I'm going to wait for the ASA to come back. While I do that, I'll change the settings. Apparently, we have 9 more minutes, so I have to rush these things along. Colors. Okay. Let's change this. Oh no. 16 bold. Colors. Green. White. Apply. So enable. Our configuration is still there. So let's just make sure that we can ping the new inside host 192.168.10.101. Okay, so that is back. All right, so now we're going to test the connection from inside host to the router. So that's from this guy. Let's telnet. So 192.168.20.2. Okay, so that is open Cisco. That's the password. And you can see I'm connected to the outside router, right? So the ASA allowed that to go by default. Now let's try the reverse. Let's come to the outside router and try to telnet into the inside host, right? Telnet to 192.168.10.101. So it's going to keep trying. I'm just going to, I'm out of time, so I don't really have time to wait for it to stop trying. So it's going to keep trying and it won't find out why. One thing that we can do on the ASA is to view what is going on. And of course, you shouldn't do this on a production ASA or something. This is a test or this is a lab environment, so I can easily turn on login and look at everything that is happening. So I'm going to try this again, and let's see what the ASA says. So it says interface TCP connection denied from this. So TCP connection denied from this going to somewhere on the inside, and it's a SIM packet. Now that's because it's going from a lower security level to a higher security level, which is what we explained before. As you can see, the inside host, that's this guy, could easily get to the outside host because it was going from 100 to 0, but then 0 couldn't get to 100. I'm just going to exit out of here. One thing I would like to show you before we run out of time, or two things I would like to show you before we run out of time, is if you ping, so if I ping from the inside host to the outside host, notice what's going to happen. The ping packet is going to fail, which goes against our default traffic flow analogy. Now, why is it failing? Is it because it's not getting to the outside router? Debug IP ICMP. I'm going to ping. So as you can see, it's actually getting there, and the outside router is trying to reply. But the problem is the ASA doesn't include ICMP as the default stateful inspected traffic. So ICMP is not included as stateful as the default stateful inspected traffic. So that is why this is going to fail. There are two ways you can accomplish something for you to go through. I'm not going to tell you. You can find it out yourselves. That feels good. Feels good holding knowledge. That's bad. Okay. So the last thing I want to show you before our time runs out is how do we alter the default traffic flow, right? So for example, if this outside router needed to connect to an inside host, usually it's not an inside host, it's a DMZ, but in this case it will work for us. So if this outside router needed to be able to, for example, telnet to the inside host, what do we do and how do we allow that connection? What we do, or what we use to override the default traffic flow, is access list. Yeah. So on the ASA, I'm just going to stop login, and we can create an access list. It's quite similar to your iOS. The only difference is when you're creating access list on the ASA, you don't use wildcard, which for me, or at least at that time, for me, I think it was a huge relief where I don't have to be converting to wildcard mask and things like that. But on the ASA, you just use direct network mask, and it makes everything pretty like easier. So I can call this out in, and I can permit TCP from, let's assume I don't know any all the hosts coming from outside, but I'll permit it to just one particular host, 10.101 on port 23, right? And I'm going to apply that access list out in in the inbound direction on interface outside. Maybe some other training session will talk about all these access list and access group commands. Just know that the way to alter the default traffic flow is by using access list. So right now, I'm going to try to telnet again from the outside router. Yes, I haven't set a password. Just so you don't think I'm lying about it, let's set a password. Cisco. Cool. So we have connection to the inside host. So I'm just going to save this configuration. Save this configuration. I didn't do anything to this one. So the first thing that we learned about was different firewall technologies, static packet filtering. Someone needs to mute their mic. Static packet filtering, stateless or stateful packet filtering, the proxy firewall, and then deep packet inspection. We also looked at the different firewall products that we have from Cisco, and we saw how the 5500 series is now end of life, and Cisco has kind of moved to the 5500X series. We saw the next generation firewall services, including the web security essentials, the application visibility and control. And then we spent some time looking at the concept of the ASA, security levels, default traffic flow, using the waterfall model, the fact that water can only flow from a higher level to a lower level by default. We also saw the different firewall modes, that's the routed and transparent. And lastly, we saw the security context. So that's like you can have single or multiple. Multiple is like using virtualization. And then we went hands-on, although we had some technical issues. I should call it speed issues. But then we saw how the security levels work and how the default traffic flow also works. And then we saw how to override that default traffic flow. This brings us to the end of this particular training session on the introduction to the Cisco ASA. And now I'm just going to wait for questions. For those on the call, you can unmute yourselves one after the other so you don't have like feedback, and then ask questions. And then for those that are viewing, you can just leave your questions using the question and answer app. Tolu, do you have any questions or comments?
Well, off the top of my head, I'm thinking about the next thing. So we know how to configure firewalls now. Where do we go from here?
Okay, this has just been like a more or less like a prep video looking at the ASA in like a very high level ASA overview. What the ASA is very wide and is very deep. It has different features like you can use the ASA for NAT. You can configure different VPN. At least those two features of the ASA are very important, NAT and VPN. And then those topics in themselves are topics that are very, very deep. So right now that we have looked at the introduction, the next training that we're going to have on this, that's the next training that we're going to have on the next security training that we'll have on the ASA. We'll look deeper into configuring the ASA. We'll look at routing protocols. We'll look at, if we have time, we'll probably have to look at NAT. And then in a separate series, we'll look at VPNs and things like that.
Okay, sounds great. I just want to drop in here that if you do have any questions or if you do have any suggestions, you can always drop a line on the event space, or you can ask a question or drop a comment on the YouTube video of topics you like to learn about and things you like to learn. So don't always hesitate. Even if you think that you want to learn about VPN right away and we're still talking about routing, you can also try to just drop a line. And even if we can have a session, maybe we can have a one-on-one with you on the topics that you really want to learn.
Yes, that's something that we're looking to do. Have one-on-one sessions for people who may be interested in like different topics. So like Tolu said, drop us. You can add us on. You can add us to groups on Google Plus, on the YouTube channel. So you can also drop your comments, and then many of you have, or you can also get our email addresses. All right. Thanks for joining. See you in the
Thank
next
you.
article. Oh, yeah. Sorry. I write articles a lot. See you in the next video. Bye.
All right. Thank you.
Thanks. Yeah.
Podcast.